Mekong region is an area of extreme natural events. Every year you have major floods, you have major drought events, you have coastal storms and high king tides of up to 15 meters. Hundreds of people die from natural events every year in this region. When populations increase in those areas, when we start to chop up the natural landscape, the impact of those extreme events becomes more serious. With climate change, of course, we have evidence that things will get worse.
Although rainfall may become less predictable, there are going to be probably higher intensity storms, and those are the ones that do the most damage.
There's going to be more and more opportunities for loss of road infrastructure, loss of bridges, culverts, irrigation systems, very high levels of landslides causing flood situations. So you can imagine that the issue of investment in infrastructure with climate change is becoming a pretty acute sort of economic concern to governments. The bill is mounting. We are working in 3 provinces in northern Vietnam: Song La, Thay Nguyen and Bacan. Each of them suffer serious floods and widespread landslides and storms every year. And those events lead to loss of life and damage and destruction of property and infrastructure.
We're looking at mainly rural communities whose livelihoods depend very much upon agriculture. So they're very susceptible to changes in the environment.
The whole area is a fabric of streams and rivers. And those streams and rivers every year can change course, have pressure put on their banks. But people are establishing their agricultural field right up to the edge. People are building right up to the edge. So the losses to a family can be massive. The normal response of governments in this region is to bring in heavy engineering.
Traditional engineering has major advantages in terms of its ability to withstand bigger impacts, but it has different downsides in terms of cost, and it will use up natural resources, and it's not a green solution. It also usually requires people from outside the community. It usually requires bigger access, causes a bigger mess when you're constructing.
It's much more expensive. It requires materials that aren't available locally, and it requires heavy engineering. But the experience is that the more we engineer the environment, the more serious the failures taking place across the region. We're not seeing that concern for more sustainable technologies that build in strength, build in resilience. Now, the answer that we're promoting, and increasingly good organizations like Asian Development Bank and World Bank are promoting, is to bring nature back into our development. Bring nature back.
Out there in the real world with physical structures, you can do things with plants that will help to strengthen them and protect them. Worldwide, there's a huge history of using plants to protect slopes from erosion. And this is in Asia, it's in Central South America on terraces, and that's where bioengineering comes in.
Bioengineering is primarily using the tools that nature provides as kind of ingredients for infrastructure or construction, and capitalizing on their structural properties that can be used for infrastructure.
It's being promoted by aid agencies based on this success, and there's a huge opportunity for a lot more protection and stabilization with a much lower budget and with local benefits.
Local communities can be involved in the construction. They have a capacity to maintain it because it's a simple system. They get other benefits if we use plants that are useful for them. So it's a multi-purpose use infrastructure. And ecosystems adapt, building resilience to changing situations.
So that's what we're trying to introduce at the request of government into Vietnam. And the challenge is, of course, that it's not yet an authorized technique. So we are building demonstrations now and trying to raise awareness.
We're doing two main things. We're working on rural roads to demonstrate how bioengineering might stabilize slopes. We're also working on stabilizing river embankments as a demonstration.
We're trying to introduce Vietnamese technicians at different levels to these ideas so they can be involved with the process, see how it works, and then hopefully become champions for the cause within the ministry.
The objective of the project is to use a demonstration as a focus of training and capacity building, not only with national managers, but with the local contractors and local communities, starting the local communities realizing that in fact they can have an important role in infrastructure development.
So the process begins with the site selection, doing a very thorough geotechnical assessment on what would be a suitable site, followed by a very detailed topographical survey.
242.
Okay, I've got 284.
Following that, we create a detailed design of the appropriate plants, exactly what measures would be put in where. It goes through a lengthy process of approvals, and then once we get through all those stages, then we can begin construction. We enlist a local contractor to construct the demonstration for us with supervision from our consultants. We get the local community involved as well, which is really important.
In each of our three provinces, we have the advantage of being able to pair conventional infrastructure with bioengineered approaches in the same location and addressing the same problem.
So just a few hundred meters upstream from one of our riverbank demonstration sites, we can see a conventional approach to riverbank erosion control, consisting typically of a large concrete retaining wall. These structures are very effective at protecting a localized area. However, where you tend to see problems and erosion occurring around the edges of these structures or on the opposing banks or adjacent banks further downstream. These structures are also considerably more expensive, capital intensive, and over the very long term they will deteriorate if not properly installed or maintained.
Is a several $million steel and cement wall a wise use of scarce development resources? Will it become more of a burden than a benefit in the long term to affected communities?
So what we have at this demonstration site are 5 different bioengineering measures. So we put a combination of different solutions to see how they fare in these conditions. So the first one we have over here is the brush layer with the riprap at the bottom.
And next on from that, we've planted live poles. Further along from that, we've got what's called a vegetated gabion, which is essentially a large cage that is filled with rocks and rubble, but also with some live poles planted within the structure that will provide extra support as the roots take hold.
And then the next measure across is the live fences.
And at the base of the live fences, we've got a vegetated riprap, which is similar to the gabions but without the cage.
And at the very end there, we've got vetiver grass, also with the live posts and the gabions at the toe.
Đầu ra dự kiến của dự án thì với 4 cái mô hình trình diễn, chúng tôi hy vọng sẽ tìm ra được những cái công nghệ tốt nhất, những cái giải pháp tốt nhất bằng cái công nghệ sinh học để mà phục vụ cho cái việc phòng chống sạt lở ở các cái đường giao thông cũng như là các cái bờ sông, bờ suối.
An important feature of green infrastructure, which we need to bear in mind, is that it can take longer for bioengineered systems to establish themselves.
So here we got a few signs of life. We've got a few little sprouts here, so that's starting to take off. So these are alive, and these will start to grow, and then at the same time the roots will be going into the soil as well.
The plants are most vulnerable in their early stages. That's when their roots haven't quite taken hold yet. The soil is still quite loose from the construction.
And at that time, you need pretty intensive community watch and involvement.
Cái hôm vừa rồi mực nước lũ lên đến đâu?
Theo cái rác này chú nhỉ? Mà lên đến đây thôi. Nó đang lũ bé thôi, chưa to, chưa lớn. Đến đây đây.
If there's a significant percentage of failure, we have to replace them, but so far it looks pretty good.
Following construction, we go back to the site and we set up a monitoring system so that we can see how the site changes and evolves over the year. So for each cross section, you can see we've got a nice profile here, which shows how the riverbank's looking at the moment. And so what we're going to do is we're going to return to the same site periodically to see how the slope has changed over time and what the effect of our bioengineering measures have had on the overall contour of the riverbank, of the channel.
The results so far have been very encouraging. We've had local, provincial and district and commune officials coming in to watch the process as it unfolds, and we already have some good, stable systems in place, and there's a lot of excitement.
Đang đưa vào vận hành khai thác, vào với chuyện là cái kè này thì hiện nay đang trong giai đoạn thí điểm, nhưng thực tế chúng ta nhìn cũng tương đối rõ. Cái kè này là kè sinh học sử dụng các cái vật liệu của địa phương, vật liệu dễ làm. Thì tôi mong muốn là về lâu về dài thì cái này sẽ được nhân rộng cho địa bàn không riêng trên địa bàn tỉnh Sơn La và có thể các tỉnh khác của toàn quốc trong Việt Nam này.
Seeing is believing in this region, and if you show it working, then what was a pilot can then be extended or replicated to other pilots. And eventually there's a momentum of commitment to reform so that those pilots influence design standards and legislation.
So we need a geographical distribution of demonstrations. And we need a system to get people to visit them and understand them. And behind all that, you have to have the development of the codes and standards and the development of the training.
Looking long term, the main thing is to try and change the way we do business in infrastructure development. It's to change the way engineers plan and design infrastructure. So it's not a knee-jerk response to go for grey technologies. The first question we need to get engineers to ask is, can we solve this problem by bringing nature back? If yes, what are the green infrastructure technologies we can bring in to solve that problem? It's not altogether about bringing plants back, bringing green stuff back. It's about better design also of grain infrastructure, appropriate size culverts, appropriate materials on road surfaces. So we do need to form or create a movement, a green infrastructure movement in this region, which is built on demonstration, training and networking. We need resources to bring together engineers and city planners and infrastructure planners to start sharing with them the results of the demonstration. So there's a number of investments that are needed over the next few years, quite urgently, because with every failure, we're building a future which is undermining resilience for increasing extremities in climate.